Welcome, Algebra 2. This video is on writing an exponential function. The essential question is, what is the difference between exponential growth and decay? Let's begin. So here's a reminder, this is the exponential function. If your b value, which is the base of the exponent, is between 0 and 1, then it is going to be decay. If the b value is above 1, then it's going to be growth. So for example, these three equations are growth, where your base is 2, 5, and 2. And these three are decay, where your b is going to be 2/3, 1/5, and 2. Those are between 0 and 1. Let's look at a model to model exponential growth for real problems. So the function says an amount a after period t, so a, this is like a of t, you can just think of this as just capital A, equals little a times the quantity 1 plus r to the t power. And what do all those variables mean? Well, a is what you end up at the end. Your little a is your initial amount, how much you have at the start. This rate, this rate is like how much you're growing or decaying. So usually if we're talking about percents, like you're going up 10% a year or down 10% a year, that's what that r is. And then t is the number of time periods. So like if you're doing it for 5 years, your t will be 5. Like if you're counting every 5 times. So we use this a lot of times if you're talking about interest in a bank account, or sometimes like cell counts or other things that experience exponential growth and decay. So here's an example of that with money. So let's say you invest $1,000 in a savings account at the end of 6th grade. The account pays 5% annual interest. How much money will there be in the account after 6 years? So we have our equation here. We just got to figure out what the values are from the sentence up here, from the word problem. So the first sentence says you invested $1,000 in a savings account at the end of 6th grade. So this is actually what you start with. So you're starting with $1,000 at the start. That's going to be your little a. So your little a is going to be 1,000. Because that's what you start with, your initial amount. Now, the end of 6th grade. Okay. The account pays 5% annual interest. So that, when you ever see a percent, we're talking growth and decay, that's how much it's growing every time. And if it pays 5%, you have to think about what does that mean. Is that 5% more or 5% less? But if it's paying you, you're getting more. So your r is going to be increasing by 5%. It's 5%, but you don't just say 5. What you actually have to write that as a decimal, that's going to be 0.05. And now, let's see, what else do we need to find? Annual interest, so it's paying you once every year, so our time is going to be in years. How much money will there be in the account after 6 years? So what's our time? How many times are we counting? We're counting 6 times because we count every year, and we do it for 6 years. So your t is going to be 6. And then we got to figure out what we're trying to find is how much money you have at the end. And the how much you have at the end is the big A. This is what we got to find. So I'm going to plug in all those numbers to the equation. My A is going to equal little a, 1,000, times 1 plus r, so 0.05, all to the 6th power. And I figure out A at this point, I can combine this, so 1,000 times 1.05 all to the 6th power. And at this point, you want to type into a calculator. So I'm sorry you can't see my calculator. I'm going to type it in. So 1,000 times 0.05, all of that to the 6th power. Make sure you watch your order of operations. And what you get for A is I'm getting $1,340.10. So that is how much you have in the bank account if you're getting that interest rate and you save $1,000 after 6 years. All right, let's try something else. So next thing. Euler's number. So this might be new to you. You know what pi is. You've seen that before when we're talking about circles. And it's usually rounded to 3.14, and it actually keeps going on and on forever. You might have learned that. We have another special number, and this is called e. E is about 2.718281, and it repeats on forever, just like pi. Usually we just round this to 2.71. It's also, you might hear it Euler's number, natural base. This number appears a lot, especially when we're talking exponentials and logarithms. It's got a lot of neat properties, but we're just going to start using it today. And as we do more of this logarithm unit, you'll see it used more and more. So one way we use this in the concept called continuously compounded interest. That last problem, your interest happened every year, like only once a year every year. This is, you're gaining interest all the time. So it's a different type of interest. So we still have our A, or amount that you have at the end, and in terms of t, so you can kind of ignore that t. So equals the principal, that's what you start off with, this is what you start, times e, that's the new number you learned, to the power of the interest rate, so that rate times the number of years that you'd use that. So sometimes you'll see this a p e to the rt power. So let's actually use that. Try that problem out. So continuously compounded interest. Suppose you won a contest at the start of 5th grade that deposited $3,000 in an account that pays 5% annual interest compounded continuously. How much will you have in the account when you enter high school 4 years later? Express the answer nearest dollar. So how much you will have in your account at the end, that's what we want to find out. So A is what we're trying to find. Now what's our P going to be? Our principal. Well, that's what you start with, and you start with $3,000. And you know what E is, 2.71. Your rate, it's 5%. It pays 5%, so that means you're gaining 5%, so it's going to be positive 0.05 as a decimal. And your time, how long are you doing this for? Well, you're doing this for 4 years, because you're doing this when you enter high school 4 years later. So 4 years. So let's plug all that in. Your A is going to equal 3,000 times E to the R, 0.05 times 4. So you plug those into your calculator, and I'm sorry if you don't have one, but I'm plugging those in. And make sure if you don't have a calculator with E, you write 2.71. And what you come out with is your amount you have in the account is $3,664.21, but rounded to the nearest dollar is $3,664. There you go. All right. Now, last thing. We'll talk about translations of exponential functions in class. We've done those for quadratics. I'm just going to say, here's this here. I might write this in your notes, but I'll save this for a classroom activity. And let's do some examples. All right, suppose you invest $500 in a savings account that pays 3% annual interest, 3.5%. How much will be the account after 5 years? So we want to know how much is in the account, so we got to find our A. That's what we're trying to find. And little a, what you start with, is $500. And your rate is going to pay you 3.5%, so it's increased by 0.335. That's 3%. And your time is going to be after 5 years. So I plug all those in, you get 500 times 1 plus 0.035 to the 5th power. So again, you'll need a calculator for this, so 500 times 1.035, all that to the 5th power. And what I get is I'm going to get $4,156.90. Next one. Pause the video. All right, suppose you won a contest start of 5th grade that deposited $3,000 in an account that pays 5% annual interest compounded continuously. About how much will be in the account after 4 years of high school? Similar to one of the earlier examples, but a little different. So our principal we start off with is $3,000. The rate is going to be 5%, but the amount of time is different. So you start in 5th grade, so after 4 years of high school, that's after 12th grade. So that is going to be 5. You start in 12th grade, and you start in 5th grade, and after 4 years of high school, so after 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th, that is going to be 8 years by my count. No, it's not. 12 minus 5 is 7, because you have to count all of 5th grade and all of 12th grade, because it's after 4 years of high school. Let's see. So that example is going to be A times 3,000 times E to the 0.05 times 8. And if you plug that into a calculator, you get 3,000 times e to the power of 0.05 times 8, and that gives you $4,475, roughly that. That's good enough. And that's it.